Hello everyone. In this video we'll be doing a quick PLS SEM run, maybe in 10 minutes. The idea is that I want to show you all the necessary steps of running PLS SEM analysis with as simple and quick explanation as possible. So let's do it. Okay, so in order to do PLS SEM analysis, we need to understand that PLS SEM analysis are divided into parts. Number one, the measurement model that you see here, indicated as the outer model, and number two is the inner model, also called a structural model. Essentially what we do in the measurement model, we check reliability and validity of our data, and in the structural model here, you see in this orange box, we check the hypothesis of our study, in which we want to check the relationship between one variable and the other variable. Okay, so if you understand that PLS SEM is basically has two steps. Number one, the measurement model called outer model, and number two is the structural model, also called inner model. We'll move on to Smart PLS. Okay, so here I have my model, in which I have responsibility, activity, identity as independent variable, affection as mediating variable, and then engagement as dependent variable. Okay, so what I want to do, number one, like I said, we first will do the measurement model, and then we'll do the structural model. So for the measurement model, we'll go here, we'll run PLS algorithm. Okay, so if you see here, just leave everything as it is. Just make sure you have path selected here, and missing value. Again, by default, everything is mean replacement, and just run it. Okay, start calculation. Usually, measurement model, you can run within few seconds. Okay, so the first thing we want to do is we want to do a few things here. Number one, we want to do a multi-collinearity assessment. Number two, we want to do a reliability assessment, and number three, we want to do validity, and we'll have two types of validity: convergent validity and discriminant validity. Okay, so let's go back here. And let's do one by one. Number one, collinearity statistics. Also, in Smart PLS, we do it by checking VIF values. Okay, so let's go straight to VIF values and click on inner VIF values. Okay, so the criteria is VIF value should be below 3.3. If our values here are below 3.3, we can say that there is no multi-collinearity issue in our data. Okay, so we're done with collinearity. Let's go click on construct reliability and validity. Now we want to check the reliability of our data. We have three types of assessment here. Number one, Cronbach alpha. Number two, rho. And number three is composite reliability, also called CR. Okay. Ideally, these values, whether it's Cronbach alpha, rho, or composite reliability, all should be equal to 0.708 or above. However, in some cases, like you see here, we may have below 0.70 value, and for that, Smart PLS automatically highlights them in red. Okay. In most cases, we report Cronbach alpha and CR. However, the newest knowledge, the newest debate says that on PLS SEM says that rho is probably a better measure to report. However, again, I would say Cronbach alpha and composite reliability are the most reported assessments for reliability of the data in the published research. Okay, so if you're done with so it's up to you, whichever you want to report. For me, Cronbach alpha and composite reliability are good enough. Okay, next we want to check the average variance extracted, which is the first type of validity. For average variance extracted, basically the criteria is the value should be 0.50 and above. And here you can see all my values are in green because my values, the AVE value is above 0.50. Okay, the next one we want to check a discriminant validity. So here we check average variance extracted. That means we want to check some of the shared variance among all the variables in our model that we believe that it should be 0.50. Then it has some convergent validity. On the other hand, if you want to check the discriminant validity, which is a requirement, we should be checking discriminant validity. We have three type of assessment. We have Forno locker, cross-loading, and HTMT. Discriminant validity essentially establishes that there's enough difference between the concepts we are checking, we are assessing. So there's no there's no huge, or there's no a type of overlap between two variables that there is no where somebody could argue that your respondent could not even discriminate between any two variable that you are assessing. And if you see in our data, according to HTMT, responsibility and activity has responsibility activity has values in red, because the HTMT value should be below 0.90, and because in this case it's above 0.90, Smart PLS is indicating is in red, which essentially means that we at least for these two variables our data does not show enough discriminant validity. And as a result of that, if we are reporting HTMT and we have this type of situation here, we probably wanna remove one of these two variables, either responsibility or activity. Okay, so let's go next. Let's go to cross-loading. Okay, so for cross-loading, we can also report cross-loading for our discriminant validity. And essentially, the idea of cross-loading is that, for example, this ACT1, ACT2, ACT3, they all relate to activity. And the idea is that these items of activity should load highest with itself, right? With themselves. And if you look at activity, has the highest value here with activity 0.842, 759, 770. With all other variables, the value is much below. The same goes with affection here. If you see the affection has the highest loading value with affection, with themselves, and with other variables, these values are below. So according to outer loading, our model has no issue of discriminant validity. However, HTMT showed there is an issue, and actually HTMT is the most advanced one, and I prefer to report HTMT than any other type of criterion. Okay, so the last criterion for discriminant validity is Forno locker. Similar to cross-loading, Forno locker value should be highest with itself, and here we can see that activity has the highest value with itself, and then affection has the highest value with itself, and then with engagement and identity, again, all these values are small underneath, so it has the highest value with itself, and the same goes for responsibility. So again, it's a choice of a researcher, which of these criteria, one or multiple or all of these criteria they want to report. I usually prefer HTMT. Okay, so we are done with let's go back to our slide. So we are done with the measurement model. We have already assessed multicollinearity, reliability, validity. Let's do our structural model analysis, in which we'll be running our we'll be checking actually our hypothesis. So when we want to do a structural model analysis, we'll go here and we'll run bootstrapping. Okay, we'll run bootstrapping. Okay, just want to remind the viewers that you should make sure that do parallel processing is checked here. We have complete bootstrapping check here, and then we have bisected. This should be checked bisected, and then I prefer to have one-tailed clicked here. And usually what is most recommended is that people run subsample of 5,000. However, just for this research, just to make this video quicker, I'll be running 500, because if I run 5,000 like this, my software is going to take a while. And so just for the sake of this video, I'll be doing 500, but it is highly recommended you do 5,000 subsample. Okay, rest we leave as it is, and then let's run it. Okay. It's going to take a while. When we'll be doing moderation, it's going to take even longer. Okay, we're almost done. There you go. We have the results of bootstrapping, which essentially means we have the results of structural modeling. Okay. So in structural modeling, number one, we want to do the path coefficient. Here, when we select path coefficient, when we click on path coefficient, we get to see these results here. Path coefficient shows the direct relationship between the variable in our model, and this shows the relationship between activity and affection and engagement, identity and affection, responsibility and affection. Let me show you the model here. So this model here, if you see that path coefficient will be checking the relationship between responsibility and affection, activity and affection, and identity and affection, and then relationship between affection and engagement. So all the direct relationship we can check by click on path coefficient. And the rule says that, so basically when we report structural equational modeling results, structural model results, we report three type of conventionally we report three type of values here. Number one, these beta coefficient values, and number two are t-statistics value, and number three is p-value. Okay, so whatever beta coefficient value comes here, we just report that, and likewise we do the same with t-statistics. And with p-value, we just need to understand what p-value means. It's also called a probability value, also called the significant value, SIG. If the p-value is below 0.05, as you can see that Smart PLS has highlighted as in green, which essentially means this p-value is below 0.05, which means that our hypothesis is accepted here. Our hypothesis, which says that activity has a relationship with affection, is accepted according to our data. Same as with affection, same as with identity, same as with the responsibility. The responsibility has been rejected. And why it has been rejected? Because the p-value is much above 0.05, and you can see that Smart PLS has highlighted is in red because this value is above 0.05. Okay. One more thing I want to tell you before I move on to mediation. When we report a t-statistic, we just want to make sure that these t-statistics value, just want to tell you how it works. When the t-statistics value is above 1.96, whenever it's above 1.96, you will see the p-value below 0.05. And whenever you will see the t-statistic below 1.96, you will see here p-value is above 0.05. So when we report t-statistic, we just want to make sure that all of our if you're claiming any hypothesis to be significant, the t-value of that hypothesis should be equal to 1.96 or above. Okay, so now we're done with the direct hypothesis. What if we had the other hypothesis, which says that affection has a mediating effect between responsibility and engagement? And likewise, what if we have hypothesis which says if activity has a mediating effect between, affection has a mediating effect between activity and engagement? And likewise, we would have said the affection has a mediating role between identity and engagement. If we have this hypothesis, then here specific indirect effect, these values are extremely essential for us to understand and report. Okay, so like before, if you see here, so if you see here, instead of 2 now we are seeing 3 variables relationship here. So essentially what this path means that they're saying identity has relationship with affection, affection is relationship with engagement. It's also called indirect relationship. Also we may want to call it the other way, that the mediating effect of affection on the relationship between identity and engagement. And according to the p-values, it's a significant relationship. It's a significant. That means if we have a hypothesis, hypothesizing for affection as a mediating variable between identity and engagement, then our hypothesis would be accepted here. Same as here. However, this here the mediating effect of affection between responsibility and engagement turns out to be insignificant. Hence, if we had a hypothesis related to this, that would be rejected. Okay, so we're done with direct relationship and hypothesis and mediating effect. Let's do our moderation. Okay, look, I have designed here the same model I had used before. The difference is that now I'm taking affection as a moderating effect. So if you're saying that what if our hypothesis is this, the responsibility has a moderating effect on the relationship, affection has a moderating effect on the relationship between responsibility and engagement. And again, what if our hypothesis is this, that affection has a moderating effect on the relationship between responsibility and engagement? So in this sense, what we are trying to do, we are saying the affection is a moderating variable on the relationship between responsibility and engagement. And if this is the case, we need to check it as a moderator. So for that, we click on engagement, we go here, add moderating effect, and number one thing, you see that dependent variable is already, so Smart PLS knows one variable that you want to check a moderating effect for. Okay, so the other variable, the other thing it want to know is that what is the moderator variable, and we know that moderator variable is affection. And as I explained before, that we want to check the moderating effect of affection between the relationship between between engagement and responsibility. Okay, so let's click on product. Excuse me. Let's click on product indicator here, and the rest looks okay. Okay, and then click OK. So now we have, look, I have affection as a moderating variable, and now I have a moderating effect, right? We call it moderating or interaction effect, and I'll rename it so there is no confusion. And we know that responsibility into affection, right? This is what we want to check. So this is our moderating effect, right? And this is what Smart PLS does. It creates a new variable, and we call it moderating effect or interaction effect. Okay, so just like before, in order to check our moderating effect of affection on the relationship between responsibility and engagement, we'll go to bootstrapping, and everything like we did for mediation. Again, we should be doing 5,000, not 500. However, for the sake of this video, I'll be doing 500, so I am able to run it quickly. The cell is going to take a while because every time you run moderation, it takes a while. It also depends on the type of the specs of your laptop or your computer. Okay, so I hope that is gonna do within a few seconds. Okay, it's done now. Okay, so now we just ran our moderating analysis, and we wanna understand what does it mean. So let me show you this model here. Okay, so this is my moderating variable, and you see a bunch of values here. Let's go straight to report, and keep in mind our focus now. We want to do just the moderating. We just want to understand moderating here. Okay, so activity, and again, when we ran moderating variable here, moderating effect of affection between responsibility and affection, this is fine. However, this relationship became insignificant. Likewise, this is what we wanted to. This is what we were actually originally we were interested in. This was the purpose of doing our moderation effect. We wanted to check if there is a moderating effect, and according to this path, there is no moderating effect of affection between responsibility and engagement, since we see this value here as 0.474, which is much above 0.05. And if you see this is the name of our moderating effect. So according to this, again, our moderating effect, if we had a hypothesis that would say there is some type of moderation going on between responsibility and engagement related to affection, then it would be rejected. Okay, so let's go back and let's take a look at what else is done. So we are done with path coefficient direct relationship. We're done with the specific indirect effect for mediation and moderation. Actually, like I said, moderation, for that we can check the moderation by checking path coefficient if we're able to create moderation effect in our model. And the last one is effect size. Okay, so instead of just explaining effect size, I'll also be explaining the R square. Okay, R square value. So let's go back to our smart PLS, and if you remember, let me show you. If you remember, we ran here mediating effect. So when we report structural relationship, which is the second step of PLS SEM, we also report R square value. For that, we'll just go back to our measurement model assessment, like I did from here. I'll go back to our measurement model, PLS algorithm, and I'll go to report, and I'll go here, R square, and there I have R square value. All right, and look here, R square value for affection and engagement. Why only for affection and engagement? Because affection and engagement are two, in other words, affection is the dependent variable for these three, and engagement is the dependent variable for this, right? So because affection, as a result of this, affection has 0.334 R square value, and engagement has 0.174 value. R square value means these three variables all together explain 0.334 variance in affection, which essentially means we're saying that affection is built by 33.4% affection is built by these three variables, which essentially means there are some other variables which are not in our model. They explain the rest of the variance in affection. Likewise, for engagement, we believe that affection explains only 17.4% variance in engagement, which essentially means there are some other variables out there which are not part of our model. They explain the rest of the variance in engagement. Okay, so engagement, if we want to understand engagement, at least 17.4% can be understood by understanding the affection effect. Okay, so we are done with R square. So usually we report R square, and we also report F square. Okay, so R square, where R square explains the total variance in the dependent variable. Effect size, what it does, effect size explains how much, if we remove, for example, let me show you. Let me go back here. So here, okay, here. So here we know that 0.334 variance is explained by all these three variables, right, in affection. What if you want to understand that how much each of this contribute, how much each of this contribute to affection, and whether that individual contribution of each variable is significant, is moderate, is substantial, it's weak, negligible, what it is, right? So while R square explains the total variance, effect size tells us the contribution in the variance of each variable, right? So let's go back to, again, measurement model, where we have a measurement model. Let's go to report, and we'll see F square here. We'll see F square here, and according to this criteria, if our F square is 0.02, it's equal to 0.02, it's weak. If it's equal to 0.15, it's moderate, and if it's equal to 0.35, it's strong. Okay, so let's go back and take a look at our F-score value. According to this, activity has 0.027 effect on affection, which means it is weak. It's just above weak, right? Still, it's considerable. And for affection has 0.210. Effect size and engagement, again it's above 0.15, which is a moderate, so it's above moderate. And however, same is case with identity. It is 0.272. It's much above moderate. However, responsibility has 0.000 effect, which essentially it has no effect in our model. And conceptually, what we should be doing is that we should be removing it from our model because it has almost no effect. Okay, so that's about it. I just wanted to show the viewers that how to run PLS SEM, measurement model and structure model with all the necessary steps that usually researchers report in their research paper in as little time as possible. That's about it. Thank you.